Number 49, page 242. Write an equation in standard form and in slope-intercept form for the line through the point 1, 6 and perpendicular to the line 3x plus 5y equals 1. So there's a lot involved in this problem. There are quite a few steps and there's a lot of vocabulary to decipher. So let's first make sure we understand the terminology being used here. Standard form of a line is when the equation of the line looks like ax, so there's some x term first, plus by, there's some b term next, equals c, some constant. So that particular order of terms, and different mathematicians and different textbooks have variations on the requirements for a, b, and c, but in our textbook, a, b, and c are integers, and a is positive or 0. So when we get to the end of the problem, we'll refer back to those things to write our equation in standard form. And then for slope-intercept form, that's the one we work with the most often. That is your y equals mx plus b, and m is the slope and b is the y-intercept. Okay, so in this problem, we're given some point, the point 1, 6. Let's kind of just visualize that for a moment. Let's say it's here, 1, 6. And there's some other line. The other line is the line with equation 3x plus 5y equals 1. I'm not going to worry about figuring out where that is, but let's just imagine for a minute that this happens to be that line. If that was the case, then we're trying to find the equation of a line perpendicular to it that passes through our given point. So that would be this line. Or perhaps instead, we have our given point, and let's say the given line was this line. We're trying to come up with the equation of a second line that passes through our given point and is perpendicular to the first line. So whatever the case may be, we're looking for the equation of a second line passing through the given point. What do we know about perpendicular lines? Their slopes are opposite reciprocals. So now that we've recalled all the basic information that we need to solve the problem, we can go ahead and get to work. Okay, the slopes are opposite reciprocals. So in order to write the equation of our line, we need to find the slope of the given line. So here's our given line, 3x plus 5y equals 1. Let's find its slope by changing the equation's form to slope-intercept form. So we're going to isolate the y, and then we can see the slope is negative 3/5. So that means that our perpendicular slope that we want for the line we're trying to find is the opposite reciprocal of that. So since this is a negative, ours is going to be a positive, and instead of 3/5, we have 5/3. So that is the slope that we are going to use. And once you have a slope and you have a point, you can find the equation of the line. We have a couple of different ways to do that. One way you can do it is you can just use y equals mx plus b, your slope-intercept form, and substitute in what you know. You know 6 is the y-coordinate of the point, 5/3 is the slope, 1 is the x-coordinate of the point, and you can solve that for b. 6 equals 5/3 plus b. Let's change 6 and call it 18/3, and we'll subtract 5/3 from both sides. So that gives us b is 13/3. We can substitute that back into our slope-intercept form and substitute the slope back in. And we have y equals 5/3 x plus 13/3. That's slope-intercept form of our answer, so that is the answer to part B of the problem. It's okay if you do part B before you do part A. Now let's go back and finish by finding the standard form of the equation. So starting with our slope-intercept form and reminding ourselves that standard form involves a particular order, the x term, then the y term, then equals, then the constant. We're going to, how about if we subtract the x term from both sides? And then also keeping in mind that a, b, and c are supposed to be integers, so we need to multiply both sides of the equation by 3. And then one last thing, a has to be greater than or equal to 0, but right now a is negative, so let's multiply both sides of the equation by -1. And that gives us standard form for our answer, so that is part A. Your other option for finding the equation of the line once you have the slope and the point is to use point-slope form. Both should work just fine.